Okay, so today is day 2 of the 7.1. Okay, and so just on day 1, I wanted to do an intro talking about how do you know what your graph will look like? Will it look like increasing or decreasing, growth or decay? And then also to link with it transformations. And so, you can read the top thing to be like, okay, the parent is b to the x, and the if b is greater than 1, it'll be growing. If b is between 0 and 1, it'll be decaying. And then also the transformations that go with it. It has always an asymptote, and it's always on the x-axis unless it's been shifted up or down. Okay, and so if you graph 3 to the x, you can make a table of that and be like, okay, this is going to be growth because the base is going to be bigger than 1. So if you plug in x is 0, you would do 3 to the 0, that's 1. If you plug in 1, 3 to the 1th is 3. If you plug in x is 2, that'd be 3 squared, which is 9. If you plug in negative 1, that would be 3 to the negative 1, which would be 3 to the first, and then do the reciprocal, so that'd be 1/3. If you do 3 to the negative 2, that'd be 3 squared, and then do the reciprocal, which would give us 1/9. Okay, so again, fractional exponents give us roots, and powers. If you do negative exponents, it does reciprocals of what you start with. And so we can graph these real quick. 0 is 1, 1 is 3, 2 is 9, negative 1 is 1/3, and then 1/9. The asymptote appears to not have shifted up or down because there's no shift. The asymptote is on the x-axis. So this is the parent of a lot of children. Okay, it's going to be 3 to the x. And so the child over to the right is a vertical stretch by 2. It's going to be right 2 and up 1. So we can go ahead and just graph the asymptote at positive 1. And so you still do need to make a table of values, but here's how I would suggest it. Start with how much left to right is. This is right 2. Okay, so it starts at 2. Okay, that's kind of the central value. You got to plug that in for sure. And then show the growth and decay, or the growth, each side of that value. So if you plug in 2, and plug it in up here at the top, you're going to do 2, and then you're going to do 3 to the 2 minus 2, which is 0. And then you're going to add 1. Okay, so we did the exponent, and now we have to do 3 to that exponent. Okay, so 3 to the 0 is 1, and then 2 times that is just 2, and 2 plus 1 gives us 3. So 2 is going to give us 3. That's kind of the starting point, okay? And then if we plug in a value to the right, we'll plug in 3. So you do 2 and then 3, and you're going to plug in 3 minus 2, which is 1. And then 2 times, 3 to the 1th is just 3. So 2 times 3 is 6, plus 1 is 7. So 3 is 7. And we get to plug in 4, see how big that gets. So 2 times 3 to the 4 minus 2 is 2, and then add 1. 3 squared is 9 times 2 is 18, plus 1 is 19. So this is 4 is 19. Awesome. It's going to be pretty high. Oh dear. And then let's plug in 1 and see what happens. Okay. So this is a little bit tricky to do, but I'm going to ask you to do it. So we're going to do 2, 3 to the, if you plug in 1 minus 2 is negative 1, and then you're going to add 1 to that. So 3 to the negative 1 is 1/3. And you have to times it by 2, or 2 over 1. You get 2/3 plus 1. That's 1 2/3. Okay, 1 and a skosh. And then you could plug in 0. Okay, so it would be 2 times 3 to the 0 minus 2 is negative 2. And then add 1. So 3 to the negative 2 is 1/9 times 2. That's 2/9 plus 1. So that's easy. 1/9, 2/9 plus 1, 1 and 2/9. Okay. Okay. And so it's going to get close to this asymptote. It's never going to go below 1. Okay. So the domain is negative infinity to positive infinity. The range is going to be from 1 to infinity, not including 1, not including infinity. And the transformations would be vertical stretch by 2, right 2, and up 1 from its parent. Okay, and so I want you guys to be pretty comfortable with identifying this. So we can graph 2 to the x pretty quick. And so x and y, So 2 to the 0 is going to be 1. 2 to the 1 is 2. Basically, you're going to double it each time. So 2 is going to be 2 squared is 4. Negative 1. 2 to the negative 1 is a half. So we can graph this pretty quickly. 2 is 4. Okay, so here's the parent function and the asymptotes right here, okay? What they're asking is, what is changed if you do this next one, okay? So this would be up 3, and that would be right 1, okay? And so could you do this graph? Probably, okay? So probably what I would do is make a table so I get a better like a better approximation of what it is. And so have I done that recently? No. So since it's right 1, I would start with 1 and plug that in. 2 to the 1, so that's 2 to the 0, that's 1 plus 3 is 4. So 1 is 4. Okay. And so it's up 3. So the asymptote will be up 1, 2, 3. So there's going to be an asymptote here at up 3. And it's going to be right 1 and up 3. Okay, and so you can kind of see if you plug in, say, 2 minus, okay, 2 to the first is 2 plus 3, that's 5. 2 is 5. So, yeah, it's going to look like this. Basically just up 3 and right 1. Okay, and so, great. The next one is going to be, see if you can figure out those transformations. It's going to be a reflected across the x. Vertically. It's going to be vertical compression by half. And that's it. Okay. And so again, since it's not shifted left or right, we can kind of start with 0. And so 2 to the 0 is 1, and negative a half times 1 is negative a half. Awesome. Okay. And so since it's not shifted up or down, it's going to have the x-axis as this. And if you plug in, say, 1, so 2 to the 1th is 2, and then negative a half times that is just going to be negative 1. And so this is kind of what the graph's going to look like here. It's not perfect, but reflected across the x-axis, vertical compression by half. So it's a little bit squished vertically. I probably should plug in 2 and see what happens. 2 squared is 4, and a half of 4 is 2, and then negative. So it'd be negative 2. So 2 is negative 2. So I did kind of get that one okay. So yeah, so it's interesting to be working on transformations yet again. Okay, so if this is the child of 3 to the 5th, 3.5 to the x, okay? Notice it's growing because 3.5 is bigger than 1, okay? And so what is the k value? How much up or down is it? So if you think about it, where's the asymptote here? Well, that's on the x-axis. So it's normally on the x-axis, but notice where's it landing? It's landing at negative 2. So really that's what it is. It's going to be j of x is 3.5 to the x and then minus 2. Okay, so it's down 2. Okay, and so kind of interesting, okay, that you can kind of just say, hey, it is down 2. How much is it up or down? Okay, the next one we're going to be talking about would be if Mr. Hale wins the lottery, how is that going to, and it yields 5% interest annually. Okay, so let's talk about that. He starts with $50 million. Okay, it's a good start. Okay, and what we're going to do is we're going to, instead of calling it 50, well, we could do this. We're going to do 50 million. Okay. And so then what we're going to say is, well, let's just say after at time 0, he has 50, and then we're going to say dollars in millions. Okay. Okay, so that's in millions. Okay, so, and this would be X. Okay, and X is the years. Okay. Okay, so this would be, it's going to increase by, what is it, 5%? So if you're increasing by 5%, you're going to have, if you just kept it at 100%, it would just be timesing by 1. Okay, but because it's bigger than 1, what you do is you say it's 100% plus 5%, and that's 105%. And percent means divide it by 100. Okay, so if you divide 105 by 100, you're going to get 1.05. Okay, see how it's just a little bit bigger than 100%? 105% is going to be what you're going to have, okay? And that's going to be increased by 5% each year. So you keep what you started with and you increase it by 5%. So to keep what you started with is the 100% you get to keep. You get to keep 100% of your money, and then increasing it by 5%, you're multiplying it by 1.05 to make it a little bit bigger every year. And so X represents how many years that how many times you times it by 1.5, because every year you increase it by 5%. So at year 1, okay, you will get $52.5 million. After 2, okay, if you plug in X as 2, you do $50 million and times it by 1.5 to the second. And you can let your calculator do that work. You're going to get 55.1. And then year 3, you're going to get 57.9. Okay, and so we can kind of show, okay, if this is going to be, this is his dollars. If we're like, if this is 50 million, okay, and then if this is 52 million right here, and this is 54 million, and you could say in millions. Okay, and so it starts here. And then after 1 year, he's at 52.5 million. And after 2 years, it's going to be at 55 million right here. So that's 56, and that's 58. And you can show the growth over time, okay? And the x-axis, which is way below, is going to be the asymptote. And so use it to figure out how much he would have in 20 years. Okay, and so if you want to figure out how much he has, it'd be f of 20 years equals 50 million times 1.05 to the 20th. Okay, if you evaluate that in your calculator, you're going to get 132.66 million. And big numbers are hard to deal with. So the calculator would give you 132 and then 660 and then some other numbers, And so if you want to say million, what decimal millions, you put a decimal, hundreds, thousands, millions, you'd put it where that comma goes, with the millions, 132.66 million. Okay. So we'll just put a decimal at the millions comma. Okay. And that's going to be how you get it in decimal form. And so, if you were doing, we'll just go with that. Okay. And so the next thing we're going to talk about would be, what if you graphed like decay? Okay, we haven't done much with decay. Notice it's going to be decay because the factor that holds up the x, okay, is a decay factor that's smaller than 1. And so this is kind of the parent of like decaying, okay, half-life, or taking something by a half. And so if you plug in x as 0, a half to the 0 is still 1. And then if you plug it to the first power, a half to the first power is still a half. A half squared means a half to the second power. That means you square 1 and 2, you get 1/4. Or you just take a half times a half, which is a 4th. You do the third. If you take 1 to the third and 2 to the third, you get 1/8. Or if you do a half times a half times a half, you still get 1/8. If you do it to the -1, you take it to the first part and you flip it over. So if you take it to the -1/2, to the -1, you get it to 2. And the -2 means flip it over and then square it, and square it. So you flip over a half, you get 4. And then you square it, you get, I said that wrong. You square it and flip it over. So you get 1/4 and you flip it over, you get 4. And so either order is actually fine. So if you graph this, the asymptote still is the x-axis because it's not shifted up or down. So both growth and decay either take off from the x-axis going uphill or land on the x-axis, coming from the left to right. And so depending if it's growth or decay, it's either going to be taking off like an airplane or landing like an airplane. And so 0 is 1. 1 is going to be a half. 2 is a 4th, and notice -1 is 2, -2 is 4, you can show, yeah, it's decay, okay? And the domain is negative infinity to positive infinity. The range is going to be from 0 to infinity. The y-intercept is 0, 1. And the asymptote is going to be y equals 0, and behavior as x goes to infinity, your function goes towards 0. As x goes to negative infinity, your function goes to infinity. So just look at the left side of the graph, it goes to infinity. As you go, your bigger values of x, your graph goes towards 0. So there we go. And now we're going to be talking about, can you write these functions? And so we've talked about it quite a few times recently that if this b value is going to be bigger than 1, it's going to be increasing. So if it's actually a 2, it's going to be doubling each time. If this number is a 3, it's tripling each time, because every time you times it by 3, it gets 3 times as big. If you times it by half, it's going to be decaying by half, okay? And other times, I'm going to give you guys a certain percent that you're going to increase or decrease. And you watched me a minute ago say, okay, if you increase by 5%, how do you do that? Well, you take 100%, which is just staying normal. Okay, if you times it by 1 repeatedly, it stays the same. So staying at 100%, you're just always, your beginning value. But if it's going to be a number bigger than 1, then it's going to go a little bit bigger each time, depending on how much bigger it is. So if it's increasing by 3%, well, that's 100% plus 3%. That's 103%. Percent means divide by 100. That'd be 1.03 that you put in that parentheses. Okay, notice it's a skosh bigger than 1. If, however, you're losing 3%, you would do 100 minus 3%. That's 97%. Divide by 100, that's 0.97. Notice, I wrote 79. 0.97, that's going to be decaying and losing 3% every year, okay, or every time you do it. So depending if that growth or decay factor is bigger or smaller than 1, that will help you discern, is it going to be increasing or decreasing as time happens? So this right here is going to be growth. And how much bigger or smaller is it than 1? So you can subtract 1 from it and you get 0.3. That's 30% growth, okay? So growth by 30%. This right here is going to be growth. Why? 1.4. Subtract 1 from it. What do you get? You get 0.4, and that's 4/10 or 40%, okay? So it's increasing by 40% every time you multiply it by 0.02. Or take it by 0.02 times 1.4 repeatedly is going to grow by 40% every time you do it. This is going to be decay. And if you subtract it from 1, you get, okay, and you can do this, you can do 1.0 minus 0.8, and you're going to get 0.2, and that's decrease by 20% each time. So decay by 20%. So every year you're losing 20%. Okay, you retain 80% of it. Okay, so you're keeping 80% each time, but you're getting rid of 20% each time. This right here is a cheat. It's not exponential because the variable is not in the exponent. So that's just a cheat. So look at the parenthesis and see, is it bigger or smaller than 1? And you can figure out how much it's above or below by subtracting that parenthesis by 1 and seeing that percent is how much it's gaining or decaying every single, iteration. Okay, every single time you multiply it. Okay, whoops. Let's see what the next page is. We got a third page. So we get to practice this. Be like, okay, if the parent of this is, this is simple growth, is a b to the x. A is generally what you start with. That's the growth or decay. That's going to be the beginning value. And then b is going to be the growth or decay factor. Okay, so it's either going to be a little bigger or smaller than 1. And so let's practice writing this. Okay, so if you're going to say, let's write a function. So you could do f of x or y, depending if you want to write an equation or function. So f of x is equal to 500. So you start with 500. You're growing by 5%. So that's 105%. Okay, divide by 100 and you get 1.05. Okay, so you divide it by 100, it moves the decimal over twice because you really want it to be over 1. So if you move this to be 1, move this to be over 2 places to match it, you're going to get 1.05. And that would be to the X. Okay. And X represents how many years you keep your money in the account. Okay. So you times at 1.05 every time you get paid interest. Okay. Now, what if you actually start with $500 and you're losing 5%? Well, 100 minus 5% is 95%. Divide by 100 to get 0.95. Notice you still retain, you keep 95% and then you keep 95% of that and then you keep 95% of that. But the truth is you're not staying at $500. You'll be decaying by losing 5% every single year. Okay. Okay, let's check the next one. Starting with $500. So you say f of x equals, and if you're increasing by 21%, okay, 100 plus 21% is 121%, and that would be 1.21. Notice you're going to be growing faster than if you just increase by 5% every year. And then if you're losing 21%, you're taking 100 minus 21. Yes, you're going to still keep most of your money, but you only get to keep 79% of your cash. Okay, and so this one would be 500, and it'd be 0.79 to the x. Okay, and so you'd see it's decaying. You get to keep 79% each time, but you're still losing, saying goodbye to 21% each time. Okay, here we go. Increase starting with $500. What's this with 500? Oh, well, who knows? Somebody's obsessed. And so we get increased by 4.3%. So 100 plus 4.3 is 104.3. That's not in decimal form yet. It would be 1.043. Because you have to divide by 100 to get it from percent form into decimal form. Okay, because this is still in percent form. Okay, you get to keep 104.3% of your value. If you're losing 4.3%, okay, you have to go 100 minus 4.3. Get a decimal, put a 0 there. Okay. And then you're going to get, I believe, 95.7 here when you subtract those two. And you can use a calc. I want you guys to kind of get used to saying, what is actually happening? How are we doing this? What are we doing to figure this out? Okay, so yeah, that'd be 95.7%. Divide by 100, you get 0.957. And that'd be to the x. Okay, so writing those functions, if I say double, you just put a 2 in the parentheses. If I say triple, you put a 3 in the percent in the parentheses. And those would be growth. If I say you're getting half of it, well, then you put a half in there. Okay, and so, and then here's one. It says your bacteria bubble doubles every hour. Okay, so you start with 10. Okay, and you're doubling every hour. Okay, and they're like, hey, can you do this? Can you figure out how much you're going to have if you wait for 15 hours? And so if you put x is 15 in this equation, then you can figure out, okay, well, then how much are we going to actually have? Looking for my calculator. I'm not sure where she went. Oh, here she is. Okay, and so we could do 10 parentheses 2 to the 15th, and your calc knows how to do this. Okay. And if you had to do it by hand, you would do 2 to the 15th, and then you times it by 10, but your calc can handle you doing 2 times 10 to the 15th. And we're going to guess how many bacteria are going to be in 15 hours. Oh, you're going to get sick. It's 327,680 bacteria. Okay, awesome. Okay, so the next thing is we're going to practice doing some word problems. Okay, and so on these word problems, first of all, we'll practice writing the functions and evaluating for a certain number of days, years, whatever, and then also working backwards, like, how do you solve this? And there's a way to use logarithms to help you solve these things. However, we're not about to learn logarithms yet. We're going to wait a little bit. So we're going to solve it by using our graphing calculator. Okay, and so tomorrow we're going to use a different method, property of equality, but that doesn't always work. So we're going to solve by graphing. Then tomorrow we're going to solve by property of equality. And then next chapter, we're going to solve with logarithms. Okay, so it's not that big a deal. So Clara invests $5,000 and she gets 6.25% per year. So that's 100 plus 6.25. Remember, got to line up the decimals. So 106.25 divided by 100 would be 1.0625 to the x. So that would be f of x equals. Okay. So that's our function. what they want to happen is how much will you have in 8 years? So plug in X is 8 and you can get your answer. Okay. So I'm going to just look and see what I got last time I tried this. It appears that can't quite read it, so I better use my calculator. Okay, so let's do 5,000. Then we'll do parentheses 1.0625 parentheses to the 8th, and your answer is going to be 8120.85. Okay, and we've got dollars and cents, so we can get dollars and cents. So that's going to be it. Okay, so that's the answer to A. Now it says, when will you have $10,000? Okay, and so this is when we're going to solve by graph and calc. So our function is, I want to get to $10,000. Okay, that's what I want my output to be. I start with 5,000. Okay. And I've got 1.0625, and I've got to the x. So if I graph each side of this equation, so I graph y equals 10,000, and I graph y equals this. Now, the truth is you've got to be smart with your window. If your y equals is 10,000, you're going to have your y max be up to 10,000, okay? Don't be kidding anybody. And you're going to start at 5,000 and you're going to get higher. So again, your y max has got to be 5,000. Your x max is probably not going to be like 100 years, but you're going to figure out where they cross, okay? And so maybe make your x max to be 30 or something, okay? And do second calculate intersection and figure out where they cross. When I did this last, let me see what I got, if I can read my answer. It appears that I got the answer to be 11.4 years, okay, approximately. Give me a decimal so I know you know how to do the calculator, and then by 12 years. If you only get paid once a year, yeah, it'll be 11.4-ish if they paid you partway through the year. But if they only pay you once a year, it's going to be by 12 years. So give me the decimal and then round appropriately. Make sure you label all those kind of cute things. Okay. So the next one, okay, very similar. You're starting with a city population that's going to be dropping by 3% a year. Okay. So the number of people you have, f of x, is equal to 15,500, and you're losing 3%, so that's 0.97, okay? 100 minus 3 is 97%. 97 divided by 100 is 0.97, and that's going to be to the x, and x represents how many years. Now it says, predict when it drops below 8,000. I don't want you just to be like magic 8-balling, trying to figure out where it is. I want you to actually solve it using your graphing calculator like a big kid. And so you're graphing y equals 8,000 and 15,500 and then 0.97 to the x. And so you're going to graph the left side of the equation where it's 8,000. You're going to graph y is equal to the right side. Again, you best make sure you're at 15,500 at least, and it's going to fall from there. And it's going to intersect at 8,000. So your y max should probably be at 16,000, okay? Your x max probably is like 20 years, okay, 20. And so check to see where they'll intersect. Second, calculate intersection, give me a decimal, and then round to the nicest value. It does appear that's going to be 21.7 years. So this would be 21.7 years, or you can say by 22 years, okay? So make sure you give me the decimal, and that if you feel like you need to round based on that, then you can, but you can wait a partial year, okay? And so to have them out, so 21.7 years makes sense, okay? The next one talks about a motor scooter, okay? If your function is like, okay, I'm starting with $1,000 scooter, okay, maybe you got a one wheel or something, and you're saying, okay, my function, one wheels are more expensive than 1,000, but pretend as if you got a good deal, $1,000 scooter, and you're going to decrease by 15%. So 100 minus 15. So 100 minus 15 is 85%. That's 0.85 here. Notice it's depreciating, so it's decreasing in value. That's what that means. And to the x. Use a graph to predict when it will fall below $100. Well, that's very sad. So you graph y equals 100. So we're going to put 100 equals 1,000 and then 0.85 to the x. And so you're going to graph both sides of that equation to see when will it have a value of $100, Sally. So it starts at 1,000. So your y max should be at 1,000, okay? And it's falling. And so you're going to get the decimal approximation of when that happens. And that will be in about 14.17 years. And if you feel like, okay, let's do 15 years, great. By 15 years, it'll be that value. Okay. Hopefully it'll retain its value much better than that. Okay. What's the difference between f of x is equal to 1.1 to the x and f of x is equal to 0.9 to the x? Well, this is going to be growth by what? How much is it bigger than 1? If you do 1 minus 1.1 or 1, you can subtract either way. You're going to get 0.1 or 10% growth by 10%. And this right here is 0.9. Again, if you do 1 minus 0.9, bring down the 0, you're going to get 0.1. This is decay. You're losing 10%. Okay, so there you go. Well, thank you so much. Have a good day.